questions that we've been looking at all week. We jumped around a little bit yesterday because we had a quick look at probability questions. Today we're back on track and we're now looking at the second question that has density involved. And as you can see, the first one was follow the formula to get 2 points. This one's much more involved and it's worth 6 points. However, the formula has been provided for us. So remembering the triangle. Oh, it's not working. Remembering the triangle. Oh, I don't want blue. Is not required. I don't want blue. Let's get green. Green is the best. So remembering these triangles are not required for these density questions. With speed, distance and time, yes they are, but let's go on here. A bit of color contrast there, and it doesn't matter which way these two are going. So we're looking at finding out the density. So we need the mass, and the mass is the weight, and then the volume is we've got here the volume. And as you can see here, we've got a bit of a backwards formula to work out. So we've got the density, and that is 8.05. We haven't got the volume. So we need to work out the volume. So we're times by the volume. And that'll equal the mass. And as you can see, that equals the mass because the mass is on top. So by looking at that formula, we have to look at, it's not in that order. Obviously, we've got mass on top here divided by volume. Mass divided by volume is density. Yes, we can see that. However, we actually need to know what the mass is. Mass being on top, we've got volume times density, which we've got the density already. We haven't got the volume. So we need to work out the volume, and it's a cuboid, or it's more than one cuboid. So if I was to split this up, I'm going to break it into pieces like that. So I'm going to work out the volume of this one first. And as we can see, with volume, don't forget volume is measured in centimeters. Well, in this case, centimeters cubed. So when it's cubed, we've got 3 measurements. So we need height times by width times by length in any order. We've got a height. So we're going to call this number 1. Okay, we've got a height, that's 10. And we've got a width of 15. And then we've got a depth or another width, but we've got the 3 measurements there, and that's 2.5. So we can work out that one in a second. With this one, it's not as simple because as you can see, there's some measurements missing. So we can see that it's definitely 3, so we can put that one in already. Because like I said, it doesn't matter which way around the measurements go. And then we've got one to work out here. Look, we can see it's 8.5 all the way along. However, it's only 2.5 to there. So that makes this one 6. Because 6 and 2.5 is 8.5. So we know we're going to times it by 6. And then we've got one to work out here. Look, well, we already know, it's not written on there, but we already know how wide it is or how long that bit is because we wrote it here. Look, just because it's not on there, we look around the shape and it's actually 15. So we've only had to find out what one spare one was there. So let's now work out that, or them both, and we add them both together and we'll have the volume of that shape. Right, hopefully calculator's not moving. Right, so 10 times 15 is 150. 150 times 2.5, 150 times by 2.5 equals 375. Top one. Second one, 3 times 6 is 18. 18 times by 15 equals 270. Add those two numbers together. It's in my calculator already, so I'm just going to be putting it in there. I've got 270, add 375. I've got 645. 645, and that's centimeters. I've got the volume of both those. I've added it both together, and we can now see what we're working with. We know that it's the density, which we were given, times by the volume, which we now have, 6, 4, 5, equals the mass. And that's what it wanted to show us. This question is worth 6 points, and I'll show you kind of where they're getting those additional points from me, because you're thinking we haven't really done a lot, but they're looking at, so it's 5,192, 5,192.25. And when we're looking at this, we can see, look, it's centimeters cubed, so that part. So the bit that's left is grams. And that's the weight. If we need to know where these 6 marks have come from, we'd look at definitely that as our final answer. Yes, that's 1 point. And then breaking this shape down into 2 pieces and working out the volume will be worth another 2 points. So that would be the 2 shapes, 1 point each, and then adding them together, a 3rd point. So you've got 3 points for working out the total volume of that shape, and the 4th point for working out the actual density, the mass, sorry. If you want to wonder where the other 2 points come on, it's so you can rejuggle this formula. So when you rejuggle this formula, you're looking at, it says density equals mass divided by volume. Well, we've got the density, but we didn't have the volume or the mass, so we had to rearrange that formula to understand that if we're looking for mass and it's divided by volume, then density times by volume would equal mass. Or if you remember what that triangle looks like with the mass on top, any numbers, any letters that are below that, the mass, we multiply them together to get the top one. So that's where the 6 points come from on that one. Let's scroll to the next question. So we're back onto perimeter and area, and these are 2 questions where, not in the assignments so much where we've got less pressure, but in the mock exams, I see some people doing perimeter answers for area questions and area answers for perimeter questions. When it comes to the simple way I remember it is, if it's a perimeter, I'm walking around the outside. So that's my garden fence. It's the white lines I'm drawing on my pitch right around the outside. It's the perimeter wall of a prison. And the area is the bit in between. So if I know I like my circles and I like talking about pizza, so my circumference or my perimeter is the crust, and then my area is all my topping. But for linking it to kind of more visual things, the cricket wicket here would be the area of that cricket wicket is the yellow or the strawberry coloured part, whereas the perimeter of the football pitch is walking right around the outside. And the difference between the two is, for perimeter, we add, and for area, we multiply. And that's the difference. You've got the same numbers. So you could have the area of this pitch will be 65 times 102, and that's everything in the middle. Whereas the perimeter will be 65, add 102, add 65, add 102, because we're walking all the way around the outside. So you need, on the perimeter, you use the numbers until you get right back to the start again. Whereas with area, you've just got the width times the length. You can use them once. Right, so let's go to the first question. We've had this question crop up a number of times, and it's already been in this mock revision or these mock exam questions, because it has so many different facets to it. We've got, that's okay there. We've got conversion. We can see conversion not once, twice. We've got perimeter, because he's going all the way around. Then we got some general mass in between, where we look at number of rolls in the fencing, and then we've got justification. Is he correct? Yes or no? And we've got a price we need to look at. So first thing we're going to do is put our stake down on the fence, and we're going to walk right round, because it's a perimeter question. He's putting some fencing up, so he's going right around the outside. He's not doing the gate. So we've got 140. And then we're going to go down this route, 110. Gates not included, 200. 54. And then 90. And we're back to our marker. The reason I put a marker in there is so I don't get an extra one, or I don't miss one out. I know where I started. And we can add all those up. So we've got 4 on that part, 5, 10, 19. 1, 2, 3, 4, 5. So in feet, we've got 594 in feet. We want it in meters because we can only buy it in meters. If we can see which way the bigger number is here, look, we can see that for every 1 meter, there's 3.3 feet. So the meters number, actually, that's going to be confusing because I've got the pounds above it. Let's do it underneath there. Right, we've got 594. We can see that the meters number has to be smaller. If we were to times it by 3.3, that gets bigger. So we're not going to times 3.3 by 594. We're going to divide 594 by 3.3 because we're going to get how many times the feet number per meter goes into our total distance around our garden. Yeah, it's garden, farm, don't know. This is fence in France. Divide by 3.3. So we can see that around his garden is 180 meters. So for that one, we did 594 and we divided it by 3.3. So we now know we've got 180 meters. So we've done one conversion and we've done the perimeter. What's next? We can see that each roll is 50 meters. If you buy one roll, you've got enough for 50 meters. If you buy 2 rolls, you've got enough for 100 meters. If we buy 3 rolls, we've got enough for 150. Still not enough because we need 180. So we need to buy 4 rolls. Oh, I'm going to put 150 in there again. That's definitely not enough. So we need 4 rolls. And each roll is costing a price in euros of 138 euros and 50 cents. And we need 4 of those. So a total cost in euros of 138.5 times by 4. I was going to go for 5 rolls, and I don't know why. 554 is a total price in euros. 554. Put it over there as well. I'll put it over here so I can see I've worked it out. We know we've worked that out. Again, we're looking at the number on the right-hand side, which is euros, is bigger than the pounds. Therefore, we're doing exactly the same as what we did below. We're dividing our bigger number, 554, by the amount that each pound is worth in euros. So that number shrinks. If we were to multiply them, yes, it's going to get bigger. So that's not the case here. Right, let's go. 554 divided by 1.127 equals £491 and 57p. 491.57. 491.57 is our answer. Keith knows that the fencing he needs to buy would cost less than £450 in the UK. He thinks the fence in France will cost more. France price, UK price. Yes, he's correct. We've changed it into pounds and we've still got £41 more than, and it's more than his price he's paying in England. Scroll it. Staying with area, and what you'll find with area or perimeter questions, they're never just area or they're never just perimeter. It's telling us a story, whether that's with Pearson, NCFE or TQ UK. They're always going to have a backstory. So it's believable. So it's functional skills. It's functional. George will cover part of the floor with tiles. And that's the wall. So my picture's incorrect there. The part of the floor is the shape of a triangle as shown. Well, yeah, maybe I need to change that picture another time. George buys tiles in packs. Each pack covers 1 meter squared. That's a bad 2 as well. And it costs £39.95p. The tiles can be cut and joined. George gets a third off the cost of a pack of tiles. Work out the lowest cost. Okay, we've got meters squared here, look. We've got centimeters here. Okay, they're part of the same family, but we need to make a decision. Where do we change our numbers? I'm going to change mine right now at the start with my measurements. If I divide these by 100, I go from centimeters to meters. That's by dividing by 100. I can move my decimal place from here 2 places in. 3.05 meters. Same with this one. 2 decimal places in, 1, 2. That becomes 3.715 meters. It now means that when I'm getting my multiplication of my area, I'm already in meters. I'm not having to then convert it into centimeters. We've got 3.05 length or width times by 3.715 equals the area in meters squared. Let's work that out. 3.05 times 3.715 equals 11.33075. 11.33075. If we remember when we're working out the area of a triangle, that's not the answer. That would be the answer if we were also, well, wonky line, tiling that part as well. We're not tiling that part as well. So we must half or divide our answer by 2. And we just got the area we need. Divide by 2, 5.665375. Let's call it 5.67. We're going to go 2 decimal places. Divide by 2 equals 5.67. And that's meters squared, because we changed our numbers to meters, and once we got the area, it's always in squares. If we're looking at volume, it's always in cubed, so it's 3. We now know how big our area is going to be, 5.675. We can cut and join the tiles, but we've got to buy a pack. A pack covers 1. So like we said before, we can see that each pack, and we need 1 pack covers 1. Well, that's pretty easy. 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. We need 6 packs. So the roll of fencing before, when I was adding up in 50s, looked like I was actually doing some maths. That doesn't look like I'm doing maths at all. That looks like I'm just doing double counting. So we need 6 packs, and the tiles costs 39.95p per pack. If you wanted to go just 6 times 40 and then take away 6 times 5p, 30p, absolutely you can do that. But we're going to go 6 times 39.95 equals £239 and 70p. 239 and 70p. When I said before, 6 times 40, we'd have had £240, and then we've got 6 take away the 5p, which is 30p, which we get 239.70. Again, the way the way your brain bonds numbers, especially with money, sometimes a little bit easier to do that. Those sort of, when I say rounding up and then taking away questions where we bond the numbers differently. And again, that's not the final price, because if George pays now, then he's going to get 1/3 off. Well, if we times it by 1/3, that's going to give us what 1/3 is, isn't it? If we times it by 0.3, that's not going to give us our right answer, is it? Because we know that 1/3 is not 0.3. 1/3 is 0.3333 forever. So it's not the same number. So we cannot change that to a decimal. So the easiest thing to do here, rather than times it by what we need, why don't we look at what we need? If he's going to get 1/3 off, that means he's going to be still left with 2/3. So we want 2/3 of 239.70, because times by 1/3 equals 1/3 off. So if we look at, we need 2/3 left, 2/3 of 239.70. How will we do that? Well, we've got the fraction here, so we know if we want to break this number down into 3 equal pieces, because it's thirds, I'll do it over here. We're going to go 239.70 divided by 3. It's a rubbish 3. Because I'm getting right to the edge of my black mat. Let me just scroll it out and do a 3 better than that. Right. Okay, I can't even move further because it goes further page. And then once we've got that number, we're going to times it by 2 because we want 2/3. Let's have a look. We've got 23970 divided by 3 because we're going to split into thirds. And then instead of just taking off £79.90, because that is 1/3, and that's what you could do, we're just going to times that by 2 because we know that's how much we need. When we've got rid of 1/3, we've got 2 left. And so 2/3 of that amount is 159.80. So 159.80 is the price, the lowest cost he's going to get. 5 points, quite heavily involved. Common mistakes that people would make there are forgetting to divide it by 2 here, not changing the units into the same unit at some point in the question. Got a croaky voice then. And then mistaking the 1/3 for 0.3. So those are the 3 common errors you would likely to see. We've got not an exam. We've got a new shape here, well, it's not a new shape, but it's a shape that you don't see very often in an exam question. When we look at shapes, how many sides they've got, we know it goes a square or a triangle first, and then the word for 5 is pentagon. I always think of it as being like a pentathlon in the Olympics. And then we've got a hexagon. So hex is 6, sept is 7, opt is 8, 9, nonagon, no. And then 10 is deck. Okay, so we've got 6. We're never going to get to octagons or more. They generally stick at hexagons. We've got a hexagon. The caretaker at primary school needs to order new tables. The diagram shows a sketch of the top of a table. The top of the table is made of 6 equilateral triangles. The caretaker thinks the area of the total table will be greater than 1 square meter. So he thinks it's going to be bigger, Crocodile X bigger number, than 1 square meter. Is he correct? For this question, it's an area of a triangle times by 1, 2, 3, 4, 5, 6. And that's where you're getting 3 marks from. Once we've got the area of 1 triangle, we've got the area of 6 because we just multiply it by 6. And we've got the width and the height. We've got 0.6 times by 0.52. Don't forget that gives you what it would be like if it was a square. So we must divide it by 2 to give us our triangle, and then we can times it by 6 because we've got 6 of them around there. Now let's go 0.6 times 0.52 equals divided by 2 equals times by 6 equals 0.936. 0.936. 0.936. He thinks it will be greater. Greater than means more than. He's incorrect. Oh, right. I was looking at something then. Maybe we could have just done, and it's not a shortcut. I'm thinking, well, there's 6 triangles. So does that mean there's 3 squares? Could we have gone 0.6 times by 0.52 equals times by 3 equals? Yes, we could. And I've done this question many times, and I just saw that then. So when we're looking at the 6 equilateral triangles, obviously if there's 6 of the same triangles, that means when we've divided it by 2 to split it into a triangle rather than a square, if we've got 6 of the same triangle, it means we've got 3 of the same square. So we could have just done, it's not a trick, it's not a cheat, it's just a different way of doing it, because 0.6 times 0.52 times by 3, and you'd have still got 0.936. However, for me, process-driven brain, I'm looking at each individual triangle, so I'm working out the area of 1 and then I'm timesing it by 6. What's next? Cylinders and prisms. Maybe I shouldn't have said to people yesterday we're going to have cylinders and prisms today, because often the most difficult questions we come across, however, probably the best to have a revision session on, purely because once you've got those circle formulas, you can work out anything to do with the cylinder, anything to do with the circle. It's just remembering which way round those two formulas for a circle go. However, we've still got another question, and we're talking about walls of a garden. Kathy has a wall around her garden. She needs to cover part of the wall with paint. Only part. The diagram, not to scale, shows a plan view of her garden. Kathy will cover one side of the wall with a paint to a height of 4 feet. She will not paint the gate. Each tin of paint will cover 6 meters squared of wall. 1 foot equals 0.3 meters. How many tins of paint will Kathy need to cover the wall? I see feet or foot, and I see meters. So we got to do some conversion there. And then we're looking at how much each tin covers. So it's not asking a cost, it's asking how many tins of paint. Put your marker in. I'm going to draw these numbers anywhere where I'm going to fit them all in order. So I'm going to go 27. I'm going to write, not really small, but I'm going to write quite small so I can do them in column so I can add them up. I'm down here now. There's no number there. But when there's no number, it doesn't mean to say we don't put any number in, because that means she's not putting that part of the wall. So we look at for the missing number. We can see that the whole side is 15 and the little part here is 8. So 8 add a missing number equals 15. So 8 add 7 is 15. That one's already in there for us, 6.5. And then it's 8 again. I'm going to struggle. Yeah, we're okay. It's going to be smaller than I anticipated, but that's okay. 5 and a point. 7 add 5 is 12, 21, 28, 34, 42, and there was no spares. It's rubbish. Put it there. 2, 3, 4, add a spares is 8. We know it's 82.5 all the way around there. That can't be right. No way. Is that right? 27, 37, 42, 52, 61, 68, 74. Okay, it can be 82. It just didn't seem like it's because there's only 3 big numbers at the top, and I'm like, no way. But obviously, yeah, that's right. We've done it twice. And the thing with the calculator, sometimes when you're doing a calculator, you think, oh, did I press the button wrong? I'll do it again. That's absolutely fine. If you're like when I wasn't so sure, it just didn't seem quite right. I worked it out again, and it is the same number. We've got a length of all the way around the wall. And I'm going to draw it like this, of 82.5. And we've got a height of 4 feet. Okay, so that's meters. This is 4 feet. So we've got a problem, and it's not a big problem, but it's a problem that we're going to solve using this formula here. We know that for every 1 foot, it's 0.3 meters. So 0.3 times by 4, because it's 4 feet, is 1.2. So we now know that it's not 4 feet, it's actually 1.2 meters. And the reason I've done one big long wall there is not to show it in a straight line for any particular reason, but all we've done is we've got the 27, yeah, then we've got the 15, then we've got the 19, then we've got the 7. So we've split it into the chunks, but I just, when I added it all up, it became to 82. So we know we're going to go 82 along. If we could add each wall up, absolutely, we could add each wall up. So you could go 27 times by 1.2, 15 times 1.2, 19 times 1.2, 7 times 1.2, 6 times 1.2, and 8 times 1.2. And you're going to get the same answer as what we would get now. However, we've added all our lengths up of our wall straight along, and we're going to times it by the height of 4 feet, which is now 82.5, which is 1.2 meters. 82.5 length times by the height we're going to paint, 1.2. So we need 99 red balloons meters squared. I can't think of that song now. Night Red Balloons Go By. I could sing it, but I'm not going to do. 99 meters squared. Each tin of paint covers 6, so we must divide our large number by 6 to find out how many tins of paint we need. 16.5. As we know, we can't buy, well, we can buy smaller tins of paint, but she's going to need 17 tins of paint. That seems like a lot of paint. I'm just double checking. We haven't got anything silly wrong there. Each tin of paint will cover 6 meters square on the wall. Yep, done that. Yep, we've done it right. I'm just thinking, wow, that seems a lot of paint to paint a wall. Need some bigger tins of paint. Wow, where's the answer there? That's just daft, isn't it? It's the answer's right there for that question, and I will go through it, but we can just follow the answer. It's a 5-pointer. What we've done here, we're contracted to paint 30 identical water tanks. He's going to have to paint the inside surfaces of the tank. So all the painting is the 4 inside walls and the floor. There's no roof. And so as you can see here, we've got the face here, 1.1 times 0.6, which is the height. And then we've got 2 of them. We've got the front and the back. Then we've got 0.8 times 0.6 for the sides. Oh, we've got 2 of them. So we've got 2 of them. And then we've got 1.1 times by 0.8. And we've only got 1 of them. So the surface area we've now calculated is each side from the inside and the floor to be 3.16 meters squared. However, he's painting 30 of them. So mistake number 1 on this question is, oh yeah, it's 3.16. Oh, he's got enough to cover that. Yeah, he's got more than enough paint. It's going to cost him £26. It's not, because we need 30 of them. So we're going to do 30 times each 1 tank, which gives us a total of 94.8 meters squared of paint we need. And we know that each tin of paint covers 12 meters. So we're going to divide our 94.8 by 12 to give us 7.9. Obviously, the shops have got it all worked out. We can't buy 7 tins because we don't have enough, so we need to buy 8 and have a little bit left over, like in our garage where we've all got tins of paint just for a little bit in. We're going to go 8 tins times by the cost, £26.99, and that is a total price of £215.92. Why is that a 5-pointer? Purely because surface area, and we're thinking, oh yeah, we've got a lid to cover as well, so we have 2 lids, so people may well also times that one by 2. So they're thinking of painting the lid, but there's no lid, it just says inside surface. They may well only do 1 tank, and so then you're going to get a different how much each paint covers. So there's some common mistakes there. Skateboard ramp, we're painting again. As you can see, there's a lot of painting going on with these exams. And with painting, there's always meters, and oh, this one's not too bad for. So there's always meters and centimeters or feet. We've always got something going on, but this one seems quite straightforward. However, it's a trapezium, but it gives us what the trapezium is. It gives us the formula, the area of the trapezium, which is this part here. Okay, so the trapezium we've got 1 of that we can see, and we've got 1 of that we can't see at the back. The rest are really visual and really straightforward to work out. So the ramp is a prism. It's not a prism, a prism. The front and back faces are the shape of a trapezium. Yeah, front and back, we've established that. All of the faces are rectangles. Brandon will paint all the faces of the ramp except the base, so he's not going to paint underneath it. He will use the formula to find out the area of the prism. Calculate a total area Brandon will cover in paint. So it's not how many tins of paint he needs, how much it's going to cost. It's a more straightforward question because we're following a formula and the saying what the area, surface area of the formula is. Right, 1 times 1.4. Okay, let's not go too overboard with that one. 1 times 1.4. And we've got another one on the other side. So that's 1.4, this side. And then we've got one at the other side. So let's put that one there. 1 times 1.4. And we've got a top of our ramp Oh, and look, that's 1 times 1.4 as well. So we're not breaking any kind of crazy formula rule just yet. We're looking at just area width times length for the 3 faces we can see. He's not painting the base, so we don't need to worry about that. We just need to worry about this part now. And it says the area of trapezium is the height divided by 2 times by A add B. It doesn't say to us, oh, by the way, A is the length of the top and B is the length of the bottom. It tells us the measurements already on this one. H 0.6 divided by 2, not times by 2, divided by 2. So our 0.6 divided by 2 becomes 0.3. And then we've got an A add a B. An A is 1, because it says there, and a B is 2.6. 1 add 2.6, that becomes 3.6. And then if we're timesing it by 0.3, we're breaking it into, let's go 3.6 into 10 pieces, and then we're going to have a third, right? Times by 0.3, not a third, and 0.3, sorry. We've now got 1.08. And we've got the front and the back, don't forget, 1.08. And we've got 1.08 because we've got trap and trap. Definitely got that right with 3.6. Yes, times by 0.3. Yes, 3.6. So 3.6 divided by 10 is 36. 36. That's double. Have we got that? Yeah, we did, didn't we? 3.6 times 0.3. 3.6 times 0.3. Oh, 3 equals. Oh, no, it's done the wrong way altogether. 3.6 times 0.3. Yeah, we did it right. I just again had a weird feeling we'd done something wrong. And then we add them all up. And we're gonna go what add 0.8, add 1.4, add 1.4 and 1.4. So that's 3.8, 4.2. 4.2 equals 6.36. 6.36. And we've got meters squared. Quite often in most exam papers, regardless of what board we're using, if we're using Pearson or we're using NCERB, they quite often give you the units, or it'll say don't put the units in, because trying to faff around putting a little insert and a little 2 in takes ages. So quite often it'll have that written in already for you. Now we are looking at the big ones. Hopefully, I know we're not on there yet. I thought we're going for cylinders, and we're not. We're talking about circles. And when we look at circles, for me, those are the only 2 formulas we need to remember. And I've scrolled down past them on purpose because I'm hoping people can remember them. But we're going to go around the outside of a circle. So the crust is circumference, because they both begin with C. And for circumference, or the crust, we've got pi, which always states in the exam, generally 3.14 for Pearson and for NCFE. So don't just press your pi button on your calculator, because it gives you the infinite pi number, times by diameter. And the diameter is measured from one point to the other side, traveling through the middle. I know it's not a very accurate middle, so the diameter is all the way across. The area, so my topping on my pizza is measured by area pi times by radius squared, and the radius is the distance from the outside to any midpoint. So from the outside of your circle to the middle, that's your radius. That's your diameter. Let's see what we have to do. Jess needs to cover a wood flooring with varnish. The floor is the shape of a rectangle and a quarter of a circle. A tin of varnish covers 6 meters squared, costs £5.41. Jess has £25 to do the whole floor. Does she have enough? For a circle, we know what a full circle is. So we're going to have to find out what a quarter is. We have to divide it by 4. So that'll give us, no, it won't. I was gonna attempt to draw a quarter of a circle in. So let's draw a full circle and split it into 4. That'll give us a quarter of a circle. We've got a square bit to work out, or a rectangular bit to work out first. That's really quite straightforward. We've got the length, 5.3, times by 2.6. That gives us all this part of what she's covering on that part as well. So let's do that. 5.3 times by 2.6. It's 13.78. 13.78 meters squared. Or a circle. And work out the area. I'm just divide it by 4. Pi 3.14 times by a radius squared. It's given us, it hasn't given us the radius up there. It doesn't say woo, woo, radius. It says it down at the bottom here, but as you can see, it's a square, or it's a rectangle all the way up. So that length or that width is exactly the same as that width at the bottom. That gives it away there because it's 2 right angles, so it's going straight up. So 2.6 squared equals our whole circle area. With BIDMAS, there's no brackets. However, there is an indices. The 2 is an indices, so 2.6 times by 2.6. That's that part done. Times by 3.14. So common mistake number 1 is getting the area mixed up with circumference. However, we haven't done. We've got it right. And then the second error for this question would be, there we go. I'm just going to add those 2 together and see how many tins of varnish she needs to buy. Well, that will be okay, but that's a full circle. So we need to do something with that first before we can add it to the rectangular part that we also need. So we're going to divide it by 4 because we want 1/4. 5.3066. 5.3066. Add our 13.78. Add our 13.78. And we've got 19.0866. With that number now, we can then look at the tins. So we've got 19.0866 total coverage divided by how much each tin covers, 6. So we divide it by 6 for tins, and we need 3.81. It's typically we go over 3, so we need 3.1811 tins. Well, we can't buy 3.18, so we need to buy 4, and the 4 tins are £5.41 each. So times by 4 times 5.41, £21.64p. £21.64p. If you worked it out, because it doesn't say, how do I word it? Because it doesn't say, it's asking you if she has enough with £25. So if you got your 19.0866 and what the heck? 19.0866 total area of the shape you're going to cover, and divided it by 6 for each tin, and got your 3.1811 tins, and then times that by £5.41, you're still going to get a number less than 25. So if you'd have done it like that and said yes, you still got enough, you wouldn't have lost any marks, because it doesn't say, oh, she needs to buy a whole tin of varnish, but it's saying, does she have enough for £25? So either way, whether she buys 3 tins, 3.1811 tins, or 4 tins, she's going to have enough money. And that's that question. We've got time. Oh, there we go. And like I said, they've rounded up to 4 tins, and therefore we got that much area there. We've got enough time for this question. Yeah, of course we have. 4 points. Circles again. Vicky is a wedding planner. She needs to put a string of lights along a wedding arch. The arch is made up of a semicircle. So semicircle. If it's a semicircle, we're dividing our number by 2. And it's got 2 straight sides. The diagram shows the dimensions of the arch. Vicky has a string of lights 6 meters in length. She thinks there is enough to go along the arch. I'm guessing she's not doing the floor. It doesn't, I mean, you wouldn't really do the floor with trip hazard and all that at weddings. It could be dangerous. So we're going to go from here. We've got 66. This is inches. And we've got meters. So we need to get a tape measure out and look at it, what we've got. Then we've got another 66 up the other side. 67 up. And then we've got the circumference of semi equals, hopefully, less than 6 meters. This is inches, so we need to do some conversion somewhere along the line, hence why it's worth 4 points. So the circumference of a circle, remember circumference, crust, we're going to go pi times diameter. Well, it's give us a diameter bottom, like it had at the other one. 2 right angles on each side mean that the lines are going straight up. So whatever it is here, it's the same here, which is the same here. Obviously, when it gets to the top of the straight line, it starts getting less because the circle starts coming in there. Diameter 55, pi 3.14 multiplied together. 3.14 times by 55 equals 172.7. 172.7. That's not the end of it. As we know, that would be the full circle. So that would be a common error made on this question. We must divide by 2 because it's a semicircle. So we're going to divide by 2. When my calculator springs up on the screen, it's disappeared on the other one. Divide by 2, 86.35. So our missing number is 86.35. We can then add our 67. Add our 67. And we've got a total distance around the arch of 220.35 inches. Right. What we're going to see here now is we've got, for every 1 meter, we've got 39.97 inches. So like we did before, this number is going to be smaller. So we need to divide our 220 by 39, 33, 30. That's going to be pen as well. Whatever. It came up as the pen sign, but actually rubbed it out. Kind of strange. We've still got that in our calculator, so we're going to divide it by 39.97, and we've got a meter length of 5.512. Yes, meters. And is it smaller than? Absolutely, 5.5. That's a rubbish 5 as well. 12 meters. Has she got enough? Yes, she has enough. Right, what I'd like to do is leave that there because I really wanted to show people, if they're in the class, that the cylinder questions, there's one there, and then I think there's one about a farmer tank or a swimming pool. The sphere, that's been in one paper ever, and that was on Pearson. It's never appeared on a NCFE paper, but you never know. So we'll have a look at it. It's got the formula there anyway. And then we've got here the farmer tank. And then we're up to where we started last night with the correlation of graphs, and we did the probability questions also. So tomorrow we'll be just recapping on the cylinder questions. They are quite involved, they're quite difficult. They're all worth a decent amount of marks on the exams. It is worth remembering that if you can work with circles, you can absolutely work with cylinders exactly the same. No difference in the formulas you've used when I get to them. No difference in the formulas you've used for a circle, a simple flat circle, to looking at a cylinder. Right, I'm going to stop the recording and stop the sharing.